Hi friends, today let's discuss about the hybridization in ethyne. Its molecular formula is C2H2 and the structural formula is C triple bond C having one hydrogen atom with each carbon atom because it is a member of alkyne family. So now using hybridization I am going to discuss about how carbon-carbon triple bond is being formed and also how carbon-hydrogen double bonds are forming. So let's start doing the electronic configuration of the carbon. Its electronic configuration in the ground state is 2s2, 2p2. This is 2s2 and this is 2p2. Now carbon in the excited state. One electron from 2s is moving into 2p. It becomes 2s1 and 2p3. This is how the configuration. Now hybridization. Hybridization is the concept of intermixing of atomic orbitals present in the valence shell. But in this case, one s orbital combined with one p orbital, not with all the three p orbital. One s and one p. It forms sp hybridization, giving two hybridized orbital. Not four hybridized orbital, one and one only combined, so giving two hybridized orbital. The remaining 2p orbital, which is not participating in hybridization, is called a unhybridized p orbital. Unhybridized p orbitals, there are two in number. So now I am going to draw for the first carbon. For the first carbon, how many hybridized orbital and how many unhybridized p orbitals are there? There are two hybridized orbitals. So 1, 2, 1 and 2. And there are two unhybridized p orbitals also. 1, 2. So hybridized orbitals are having big lobe and small lobe, but unhybridized orbitals are having the normal shape, dumbbell shape, and each orbital with a single electron. This is for the first carbon. Similarly, the same thing is happening for the second carbon as well. 1, 2, these two are the hybridized orbital and these two are the unhybridized orbital. This is for the second carbon. Now, I am just putting the numbers for the hybridized orbitals as 1 and 2 for the first carbon, 1 dash and 2 dash. 1 dash and 2 dash for the second carbon. Now these hybridized orbitals will be merging or undergoing orbital overlapping. So first 1 and 1 dash will combine. This is 1 and this is 1 dash. Because of that electron will undergo pairing. It gives sigma bond, carbon-carbon sigma bond. And now each carbon with one more hybridized orbital, which is numbered as 2 before. Similarly, the second carbon is having one more hybridized orbital, which is numbered as 2 dash before. Okay. So now I have drawn 2 and 2 dash of each carbon. Now what is happening to that hybridized orbital is that combines with hydrogen atom. There are two hydrogen atoms. One hydrogen atom will overlap with one hybridized orbital of the first carbon. Similarly, the second hydrogen atom will be overlapping with second hybridized orbital of the second carbon, leading to the formation of pairing of electron, giving sigma bond between carbon and hydrogen. This is hydrogen. The middle one is carbon. So here I have explained how carbon-carbon sigma bond and carbon-hydrogen sigma bonds are formed. Now comes the role of unhybridized p orbital. These are the unhybridized p orbital. For each carbon, two unhybridized p orbitals are there. So we need to draw the unhybridized p orbital perpendicular to the plane. First I will draw the first unhybridized p orbital. 1, now 2. And each unhybridized p orbital is having one electron. 1, 2. 1, 2. And these unhybridized p orbital of each carbon atom undergoes overlapping in this way. 1, 2. 1, 2. So two overlappings are there. Because of two overlapping, this overlapping is also called a sidewise overlapping. Because of that, pi bonds are being formed between the carbon atom. It means between the carbon atom one sigma bond and now two pi bonds. So final diagram is carbon triple bond carbon. Out of triple bond, 1 is sigma and 2 are pi. And with hydrogen atom, 1 sigma bond. So total, if you are counting the hydrogen atom and carbon, hydrogen, 2 sigma bonds are there. Between carbon and carbon, 1 sigma bond is there. So total 3 sigma bonds are there. And between carbon and carbon, 2 pi bonds are also there. So this is how the molecule is being formed. So total 2 pi bonds and 3 sigma bonds are there in ethyne molecule. So I hope you all understood. Thank you all.